Okay, we're going to look at cubic parent functions. I guess if it was cubic parent functions, we could call it the Fidel Castro. Maybe not. Okay, work with me here, people. Y equals x cubed. I know that's bad, but I saved it for the tape. Okay, where it says domain. All right, first thing, let's go ahead and do a little bit of graphing. Do you have your graphed cubic function there? Mm-hmm. You do have it on there?
Yes.
So at 1, it's at 1. So it's going to kind of curve up like this and then curve back down like this.
Yeah.
This being your x and your y. When we're talking domain, we want to look at our graph from left to right and say, okay, what numbers can I plug in? Are there any numbers that I can't plug in? No, I can plug in any number. So we'll say that domain x is an element of the reals. Or you could say the domain is all real numbers. It's the same thing. When you're looking at range, that's when you want to look up and down your graph and you say, okay, is there a maximum or minimum? Where does it go?
No.
Well, it goes all the way down here. It keeps going to negative infinity, and up here it goes to positive. So my range is going to be y is an element of the reals, or y is all real numbers. Where it says y-intercept, what's my y-intercept going to be?
0, 0.
It's right at the origin, that's correct. And we want to write it as a point, so 0, 0 is correct. How about the x-intercept?
0, 0.
Same thing. Perfect. All right, is there a symmetry? Now, when you're talking symmetry, that's when you kind of want to look at the graph and said, okay, if I put up a mirror, where would it look exactly like itself? Symmetry here is considered symmetric at the origin. Okay? It's considered, like sometimes, you know, we have that x-axis, if you fold it over, you get exactly the same thing, or y-axis, you fold it over. Well, this one is over a point. If we were to fold it over that point, and I realize my drawing is not perfect, but if you were to do that, it's symmetric about the origin.
Oh.
You can't flip it over the origin, but if you twisted it, like you were twisting a knob around the origin, you'd get exactly the same branches on either side if you twisted it one over the other.
Okay.
Does that help?
So it's exactly the same, just going kind of in a different curved direction.
Yeah, it's called symmetric over the origin.
Okay.
So, because it's symmetric about a point, not an actual line.
Okay.
Okay, are there any asymptotes? Asymptotes mean they're vertical places that the holes. Are there any holes?
No.
Asymptotes. None. Okay, let's see. I'm going to have to erase this so I can put some more on here. Okay, we're still looking. I'll label as y equals x cubed over here. And then it's talking about graphs of interval for increasing and decreasing. So, if you looked at it as this being from negative infinity to 0, which is this portion of the graph here, is that increasing or decreasing?
Increasing.
It's increasing. How about from 0 out to this way? What's it doing?
It's increasing.
Still increasing. That's correct. So where it says intervals of increase, we're gonna, because here's something that happens. Can you see it's kind of curving up ways and kind of got that kind of slant to it here, but up here it's increasing up, but it's kind of got a different kind of slant to it. So things are happening at 0, 0 that we don't know about.
Yeah.
So we don't want to just say that it's increasing from infinity or negative infinity to infinity because it's got some action going on here. So what we do want to say is that it's increasing from negative infinity to 0 and then from 0 to infinity. So we want to put two intervals of increase there because it's not increasing the same over the whole graph.
Okay.
All right? Is there any intervals of decrease? If you're looking along this, does it decrease anywhere?
No.
No.
No. So it would be none. Intervals of decrease would be a big bunch of nothing. Okay, over here where it says relative max or min. I guess max is at the top, min is here. Is there any maximums or are there any minimums?
Nope. And nope.
Nope and nope. Or none and none. Or none and nope. We can do it however we want.